Have you ever had a problem starting your car? Maybe it didn't start because the battery was dead. So you tried jumping the car, and when that doesn't work, you notice there is less than 1 gallon of gas in the tank. Perhaps the car needs gas in order to start. So you put gas in the car and it starts. This simple everyday problem can be solved using the scientific method. Scientific method involves cycles of observations, hypotheses, and experiments to solve a problem. The first step in the scientific method is to make an observation. An observation can be qualitative or quantitative. A qualitative observation uses the 5 senses: sight, smell, touch, taste, and sound. The problem with the car starting was a qualitative observation. You saw and heard that the car wouldn't start. A quantitative observation involves a quantity of something. In other words, they include measurements. When you noticed there was less than 1 gallon of gas in the tank, it was a quantitative observation because 1 gallon is a quantity of gas. The second step in the scientific method is to form a reasonable and tentative explanation for what is observed. This is known as a hypothesis. A hypothesis must be testable. Using our car problem, we had 2 hypotheses. First, we thought if we jumped the car, then it would start because maybe the battery was dead. So we tested the hypothesis by jumping the car, and when it didn't start, we formed another hypothesis. If we fill the tank with 1 gallon of gas, then it will start. And it did. The next part of the scientific method is an experiment. An experiment is a process where we make observations and gather information under controlled conditions. This is how we test a hypothesis. We performed 2 experiments in our car problem. First, we tried jumping the car. The results from the experiment led us to believe there was another problem, and it wasn't the battery. So we performed another experiment. We filled the tank with gas, and it started. This supported our hypothesis that the car simply needed gas. Another part of the scientific method is a theory. A theory is built over time from 1 or more hypotheses and their corresponding experimental results. It provides a deeper understanding of a problem, and evidence from experiments are used to design it. In other words, a proposed theory is a set of hypotheses tested by many scientists, and if their conclusions are similar, it is used to model what we observe in nature. A theory often discussed in chemistry is Dalton's atomic theory. Dalton's atomic theory was based on the premise that we could tell different atoms apart by their differences in weight. This theory proposed a number of basic ideas. Number 1, all matter is made of atoms, and atoms can't be created nor destroyed. Number 2, all atoms of the same element are identical. They have the same mass and properties. Number 3, When two or more different kinds of atoms combine, a compound is formed. And number 4, a chemical reaction occurs when atoms rearrange. The last part of the scientific method is a law. A law is a mathematical statement that explains or summarizes a group of observations, and it is measurable. A common law discussed in chemistry is the law of conservation of mass. The law of conservation of mass states, matter cannot be created nor destroyed. This means if we are performing a chemical reaction, the mass of the reactants equals the mass of the products formed. For example, when a match burns, the mass of the match isn't destroyed. It's converted to a gas, and the gas is one of the products formed. For more information on the scientific method or other topics in chemistry, visit www.nicolemabante.com.